what we're going to do now is kind of cover some implications of the work that we're doing. Remember, everything that we're working has to do with this normal curve and the implications contained wherein with areas. One thing that you need to remember, I've mentioned it a few times, but I really want to emphasize it. The total area under this normal curve is 1. Okay? So it says if the area to the left is 0.0228, then the area to the right has to be 1 minus 0.0228. Remember how we did probability of A and not A, and we said that, look, altogether, like the probability it rains and the probability it does not rain must add up to 100%, okay, or 1.00. So the probability that it rains is 80%. The probability that it doesn't rain is 20%. 1 minus 0.80, or 1 minus 80% gives you 100%, minus 80% gives you 20%. So in this case, since the whole area underneath the blue normal curve is 1, if the area to the left is 0.0228, then the area to the right is likewise 1 minus 0.0228. So I get 0.9772. And we need to use that reasoning sometimes in this work. We just did on the problem, a similar reasoning on the problem where we had to get less than a number less than the probability of finding the value less than the mean in the last video. So if the area to the left is 0.012, then what is the area to the right? So again, you're going to do, ready? We'll stop and start here. 1 minus 0.012, which is 0.988. So pretty simple concept there, very simple, similar to the probability of A and not A. And I just wanted to really clarify that and not skip over it completely. So the next question comes along. The final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Find the probability that a randomly selected student scored more than 65 on the exam. So the first thing I want to do is figure out the z-score. I always want to go to the z-score because that allows me to do some work either on the table or interpretation of the z-score. So the z-score works out to be 0.6, right? Because you're going to do 65 minus the average, which is 63, the mean, over the standard deviation, which is 5, and you get 3/5. Uh-oh. Should have been 2/5. I made a sloppy mistake. So you know what? We're going to change this question. And instead of it saying the probability of student getting a 65, let's change it to a 66. Okay? By changing it to a 66, we're going to get 3/5 out of the deal. So 66 gets you 3/5. Okay? Next up, I feel sorry about that, but I've already prepared this, so I got to go with it. Now, I looked that up on the table, the 0.6, and I come up with 0.22575. Okay? Looking it up on the table, I get 0.22575. Ooh. Here it is. Here's my graph. 0.22575. Okay? So here's 0.6. I shaded the green area. It's 0.22575 for just the green area. But don't forget the left side of the curve. So I shade that all in, and that's another 0.5. So altogether, I get 0.5 plus 0.22575, and I get 0.72575. Once again, I apologize that I made that careless mistake with the 3/5, and it should be redone as a student scored 66, more than 66 on the exam. Now, here's the catch-22 with this. What I just figured out was all of the green area. That's the probability that I'm less than a 66. Once again, that's the probability that I'm 66 or less. If I want to find 66 or more, I have to do one more step, and I have to do 1 minus the 0.72575, and that gives me 0.27425. So the probability that they would score more than a 66 on the exam is 0.27425. 0.27425. Okay, now let's go to the next question that we have to do on our chart. I'm going to make sure that when I describe this in the video, I mentioned to you guys that we should use a score of 66. Okay. All right. 2,000 students took an exam. The scores on the exam have an approximate normal distribution, which means use the normal curve and the z-scores and all that stuff, with the mean of 81 and a standard deviation of 15. Calculate the first and third quartile scores for this exam. Now, we're going to have to do this fairly quickly. As soon as I put up the z-score table, I start chewing through memory. Realize the first quartile is getting a score of 25%. The third quartile is a score of 75%. And then what's the middle 50% of the exam scores are between what two values? Well, the middle 50% are always between the first and the third quartiles, because the first quartile is 25%, the third is 75%. So if you get in between there, it's 50%. So by answering A, you'll be answering B. Okay, so remember, what we are working with here is a normal curve and our z-scores and so on and so forth, and our z-score table. Now, the neat trick here is we're actually going to have to work backwards. How is it that I'm going to have to work backwards? Now, find the probability first, okay? They give, we want to get the 25% and the 50%. So I want to look at the table and find 25%. So remember, you're finding the 25%. That's the middle stuff of the table. So 25% is between these two on the graph or on the table, and it's a little closer to the one on the left, okay? So I put those together and I get 0.67, right? 0.6 on the side, 0.07 across the top. I put those together, I get 0.67. Now, keep in mind that this 25% is less than, it's to the left of the graph, so it has to be a negative 0.67. That's the z-score. The z-score is negative 0.67. That means if I go to the z-score formula, and I think this is pretty slick, I put in a negative 0.67 for the z. In other words, we're going to solve for the x this time. We're not going to solve for the z. So I multiply by 15, and I get negative 10.05 is equal to x minus 81. Adding 81 to both sides, and I get that the score that's at the 25th percentile mark, the first quartile, is 70.95. Now keep in mind, we already found out that for an area of 25%, we're dealing with 0.67. Okay? So that can disappear, and our chart can disappear. And now I'm not chewing through as much memory. We can even make the graph disappear. Now let's see what's 25% above the mean. Well, we're going to work backwards. We know that it's going to be 0.67 for the 75% mark. This time positive 0.67 because I'm going to the right of the midway point. That's the z-score. I plug in 0.67. Do the same thing as before. Multiply by 15, then add the 81, and I get 91.05. So that's the 75th percentile, also known as quartile 3. It says quartile 1. Please know it's quartile 3. And I put these scores up here right now. Quartile 1 is 70.995. Quartile 3 is 91.05. I didn't put 91.05 there. Please keep in mind, this right here should say 91.05. Okay. I don't think I have enough memory to do the next video, so I'm going to stop at this point.